Okay, so we drew a diagonal from vertex A to all the corners that we could draw diagonals to. We drew it to the furthest one, and then we said if you took a look at these two corners and you drew a diagonal there, it's not actually a diagonal, it's just the side of the polygon, so it's not a diagonal. Then we concluded that we have two triangles. All right, let's do number 2. So from corner A, we got all these other corners that we can draw a line to. If I draw to this one or this one, that's just the side of the polygon. It's not a diagonal. Now let's draw the other diagonals. Alrighty. Sorry, not very straight, but it's okay. So we can draw 3 diagonals here. And how many triangles can you guys count in this one?
4.
4. Great. Anybody have questions so far? All right, let's keep going. I wish I could like have you guys write on this, but I can't. Okay, so let's take a look at all the other corners that we have. Okay, so obviously if we draw it to this one and this one, we just get sides of the polygon. It's not really a diagonal. Let's draw now from A to all the other corners. Doing my best to make it sort of straight, but it's not really, but who cares? Okay, I drew 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. Yeah, I drew 5 diagonals. So how many triangles do you guys see now?
6.
Yay! Great. Keep going. From A, you can only draw 1 diagonal. How many triangles do we have?
2.
Great. Okay, from A, we draw all the diagonals in. That's it. How many triangles do we have?
3.
Yay! And then the last one, draw in the diagonals. How many triangles do we have?
4.
Wait. Count again. 5, yeah. 1, 2, 3, 4, 5. Looks kind of like a shell. Kind of cool. 5 triangles. So I drew 4 lines. There's 5 triangles. There's always one more triangle than lines. Any questions on this first part? No? Okay. Let's see. Use the triangles formed by the diagonals to calculate the sum of the interior angle measures of each polygon. Okay, so we have to use the triangles that we drew to calculate the total interior angle measures. So here's how we're going to do it. Do you guys remember how, let me just draw a basic triangle first for you. For any triangle, what's the total sum of all your interior angles? So these 3. If I add up those 3 blue angles together, what is the total sum for any triangle?
180.
180, perfect. Okay, so then let's take a look at, I guess we'll start with, yeah, let's just start with 1. So if we add up this plus this plus this, that gives us 180. Okay, now I'm going to use a different color for the other triangle. This one plus that one plus that one. Oops, sorry, my hand just slipped and then it slid and then it slided. Okay, if we added those purple angles together, we will also get to 180. And if you add all the blue and all the purple, then you get all your interior angles. So then let's add it together. 180 plus 180 equals, what does it equal? 360, yes. And so for the first problem, for this quadrilateral, the sum of all the interior angles will be 360, okay? It's because we added two triangles together. All right, let's do number 2. So I'm just gonna not draw the angles in, but here we have 180 as our total sum of the interior angles of that triangle. We have another 180 over here for the total sum of the interior angles of that triangle. We have another 180 here for the total sum of the interior angles of that triangle. And last but not least, we have 180 here, which is the sum of the total interior angles of that fourth triangle. Now we add it up. So we have 180 plus 180 plus 180 plus 180. Let me zoom over a little bit or scoot over. Equals, anybody know what that equals?
720.
720. Good. And so the way we did that was we added those 4 triangles together. So this 4 represents, oops, that's not how I want to do it. This 4 represents these 4 180s added together. So it's really, instead of 180 plus 180 plus 180 plus 180, we could have written 4 times 180 equals 720, right? Okay, so let me box this as our answer. Then for number 3, I could write out 180 plus 180 plus 180 plus 180 plus 180 plus 180, but a shorter way of doing it is what times 180?
6.
6 times 180, good. And so what is 6 times 180? You can use a calculator.
1,000.
1080.
Good, 1080. Okay, and so this is the total sum of our interior angles for this shape. What about number 4? What should I do? What times 180?
2.
2 times 180, good. And that gives us?
360.
Perfect. Let's keep going. Or wait, before I keep going, here's a zoomed out version of all the ones we've done so far. Do you guys have any questions? Okay, make sure you do interrupt me if you have a question. Okay, we have 2 more. So this number 5, what should I do? What times what?
180 times 3.
Good, 180 times 3, and that equals?
540.
540, good. And then last but not least, what should I do for this one?
180 times 4.
Oh, times 4? How many triangles do we have?
5.
Yes, so 5 times 180 equals?
900.
900. Great. Let me put a box around it. All right, good job. So we finished using the triangles formed by the diagonals to calculate the sum of the interior angle measures of each polygon. Okay. And so this, by the way, is a key to the formula that we did in, just trying to scroll to the notes, right over here. So we calculated the sum of interior angles of a polygon. And notice here that we are multiplying, oops, sorry. In our formula, we are multiplying by 180. And this number in the front that we are multiplying by 180 is n minus 2. Let me show you how that appears in our skills practice that we were just doing. So remember, n is the number of sides. So on our first polygon, we have 4 sides. And that gives us 2 triangles. In our number 2, we have 1, 2, 3, 4, 5, 6 sides. 6 sides gives us 4 triangles. Number 3 has 1, 2, 3, 4, 5, 6, 7, 8 sides, which gives us 6 triangles. In each case, the number of triangles that you have is 2 less than the number of sides you have. So that's why every time we did 6 times, like for example, if we're looking at number 3, I can't point, so I'm just telling you. If we're looking at number 3, the 6 is the n-2, and then the 180 is just 180. Okay, so n being 8, because 8 sides minus 2 times 180 was the formula we could have used, but now you can see why that happens is because of the number of triangles you have. So the number of triangles you have is the number of sides minus 2, so 8 minus 2, which gives us 6. And then you take that 6 and multiply it by 180 because the total interior angles of a triangle is 180. We got 6 triangles. So 6 triangles, 6 times 180, and that's how we get our answer, and that's how the formula came to be. Do you guys have any questions on that one? Okay, make sure you interrupt me if you do have a question. Let's see, number 1 and 2 here are like the exact same thing. So let me see what else we got on the other pages. Okay, 21 through 24. Cool. Okay, we can do this. Let's do a little bit of this one. So draw all the diagonals that connect to vertex A. What is the sum of the interior angles of square ABCD? So once again, you're starting at A, okay? And then you just draw your triangles, your diagonals to make your triangles. Here's my diagonal. How many triangles did I make?
2.
2, and then I multiply that 2 by
180.
Thank you. And then I get what answer?
360.
Perfect. Good job, guys. Good teamwork. Okay, let's do the same thing for number 2. Start with vertex E though, because that's what they want. Okay, draw all your diagonals. How many triangles do we have?
4.
Oh, 1, 2, 3. Do you see the 3 triangles?
Yeah, my.
Okay, it's okay. I know. Sometimes we just like look at it a little wrong. We multiply this by
180.
180, good. And then you get
540.
540. Okay. Good. Any questions on 1 and 2? Sorry, I was gonna scroll away, but then gotta make sure I ask. Okay, wait, good, thank you. Let me look at the chat. Oh, and then there's somebody else that asked if there's office hours today. Yes. Office hours will start at either 1:30 or 1:40. Wait, no, just kidding. Today's Tuesday. At 1:30. Okay. All right, you're good now. It wasn't a question. You're just waiting. That's fine. Let's go to the next one. I think, let me see the time. Let's see, we could skip some of these. Okay, let's go on to part D. calculate the sum of the interior angle measures of each polygon. So if a polygon has 8 sides, how many triangles will it form?
6.
Good. So you take away 2, 6 triangles. And then we do 6 times what?
180.
Perfect. And gives us?
1,080.
Thank you. Great job. Good. Is
Jade?
that a question?
Yeah.
Yes.
If there's 8 sides, how do you get 6 triangles?
Oh yeah, okay. So let me just draw you an 8-sided shape. I'm going to zoom in so I have more space to draw. 8 sides. Let's see. 1. You know what? I'm going to do this with straight lines so I don't mess up. Okay, it's kind of an 8-sided shape. So let me see if I can make this a little better. Oops. Why does that happen? Okay. There we go. So here's my 8-sided shape. Okay. Let me just label it. Okay, 8 sides. Let me draw some diagonals in. Let's say I want to start at this corner. Okay. By the way, there's 8 corners. So 1, 2, 3, 4, 5, 6, 7, 8 corners. I saw a private message right now. I don't. Oh, okay. What about numbers 3, 4, 5, 6? We're skipping those. Okay, that was a quick response to that. Okay, so once again, here's our 8-sided shape, and 8-sided shapes have 8 corners. Now with those 8 corners, I can draw from that first corner, I could draw to all the corners. Let's see. I could draw to this first one, but that doesn't count as a diagonal because it's just the side of the polygon. Okay, so I'm not going to do that one. Then let's draw to the next corner. Okay, that's a diagonal. To the next corner, that's a diagonal. To the next corner, that's a diagonal. Next corner, okay. Next corner, okay. And then last corner, oh wait, that's just the side of the shape. So I'm gonna get rid of that one. So now let's count how many triangles we have. We got 1, 2, 3, 4, 5, 6. So those 6 triangles kind of count with like those 6, with those other lines you drew. The reason it's -2 is because take a look at this line, these 2 lines that we could have drawn, those 2 lines don't count as diagonals because those 2 lines are actually just sides of your polygon. So that's why from the number of sides that you have, which was 8 sides, you take away those 2. You take away those 2 not diagonal lines from corner to corner. So then that's why an 8-sided polygon will have 6 triangles.
So for every time it says like a certain number, you just subtract 2?
Yes.
Okay.
Yes.
Thank you.
You're welcome. I know I just said like such a long way of explaining that. But yeah, I mean if you like just straight up formulas, you can remember that it's just n-2, like right here.
Oh, okay. Thank you.
Yeah. So it's from the formula for everybody, okay? And then also, if you just like it visually, it's just you take away 2, and then you end up with 6 triangles. So then we take those 6 triangles, multiply by 180, and you get your answer. Let's do any more questions? Okay, interrupt me. Okay, I thought I heard something, but I'm not sure. Just interrupt me, like just feel free. I don't care if you interrupt me. Okay, so 9 sides, we're gonna take away 2 again. So 9 minus 2 is?
7.
Good, 7. So that's 7 triangles. And then those 7 triangles we're going to multiply by
180.
good. And then we get
1260.
good 1260. Okay. Let's do another one. Let's do a 13-sided one. Lots of sides. Good thing we don't have to draw this anymore because now we know the formula means that we have to take away 2 and then we get what?
11.
11 triangles. So we take those 11 triangles and we multiply by
180.
good. And then we get
1980.
good. Good job. Oh, when I wrote 1980, I kind of thought I was writing a year. Do you ever get that? It's like when you start writing stuff in the 2000s and you're like, am I writing a year? But yeah, good job.
1980s,
1980, right?
the start of the best generation.
What?
The
The
80s had the best
1990s were the best.
movies.
Okay. That's fine.
Well, the 80s, I mean, Back to the Future, Pink Floyd, The Wall,
Back to the
Clueless.
Future. You know, Back to the Future is filmed at the Puente Hills Mall.
Oh, that's crazy.
Oh, yeah.
Yeah, that's like my mall, the mall I grew up with. That's so cool. Anyways, that was a side note, but if you didn't know that, now you know. Back to the Future was filmed partially at the Puente Hills Mall
Hey,
in La Puente.
that guy got to be a time traveler, though.
Yeah, that was cool.
It's getting its own musical now in London.
Oh, really?
Oh, hell no. Oh, hell no.
Yeah.
Musicals
I wonder,
are not
will
it.
it be good or will it be bad? I don't know.
It's
Sometimes
going to be
remakes
better.
are not
It's a musical, it's bad.
Well, that's not entirely true.
We'll see.
The
When it
the
comes
whole
out,
good
we'll see if
musicals
it's
I've
good
seen
or
are
bad.
like Disney musicals.
Yeah. Okay, let's see. Should we do more of these? Let's do one more. Let's just do number 6 because it has a big number. Okay, 25 sides. We're gonna take away 2. That leaves us with how many triangles?
23.
23. Also, if you needed number 2, it's right up here, okay? That's a really ugly arrow. Let me take that away. All right, so 23 triangles. And then you're gonna take those 23 triangles and multiply by
180.
180, and then use your calculator unless you have a really quick calculator brain. What is this?
4,140.
4,140. Cool. Okay, so I'll wait here for people to copy. I'll give you guys 10 seconds and then I'll see if anybody still needs to. So if you still need to, just type in the chat. Sorry for that sound, I'm drinking water. Does that count as ASMR if I just crinkle my water bottle? I don't get ASMR, but I think your generation really likes it.
No, it's whack. It's whack.
Some people like it. I don't know. Let them like what they like.
I will, but that's not me.
Okay. Yeah, no, same. It's okay. All right. So anybody still copying? Say yes. Type yes in 3, in 2, in 1. Okay, it looks like we're not copying anymore. I'm going to scroll out. Let's go on to the next section. Let's see what we got here. Part E says the sum of the measures of the interior angles of a polygon is given. Determine the number of sides for each polygon. Okay, so we have to work backwards now. Before we had like sides. Oops, am I writing? Before we had sides, then we said the step was -2, and then get the number of triangles. And then you multiply by 180, and then you get the sum of degrees. Okay, so now we have to work backwards. So in order to go backwards, I'm going to draw a backwards arrow. And can you tell me what the opposite of multiplying is?
Dividing.
Divide by 180. So these are the steps we're going to do. Good. And then we get to the number of triangles. And then to get to the number of sides, what's the opposite of subtracting?
Adding.
Adding. So these are the steps we have to do. We're first going to divide by 180, and then we're going to add 2. So we're literally just reversing the steps that we did before. Do you guys have any questions on those?
Is this a formula in our notes?
So this is the reverse of the formula in our notes. So the formula in our notes was right here. So earlier, we were giving you guys n, like the number of sides. I'm trying to point. And then we asked for s. Now we're asking for s. Oh, no, sorry. Now we're giving you the s, and then we're asking for n. So it's, okay, sorry. It is still this formula. We're just using it in a different way. So yes,
Okay.
you are correct. It is still this formula, but we are using it in a different way. Okay, so let's do those 2 steps. First step we said was divide by 180. So you divide this by 180, what do you get?
Um, 6.
Yes, 6. And then we need to add 2. And then what do you get?
8.
8. Okay, so then this has 8 sides. Any questions? Let's do it again then. All right, so we have 1,800. I was going to say 1,800. So we have this, and then you divide by 180, and you get
10.
10. Good, and then you add 2, and then you get
12.
12.
12. Straightforward, right? Any questions? Alrighty, let's see. I'm going to use the formula this time. So let me just show you with the formula what it looks like. Let me show you the formula again. S is equal to n minus 2 times 180. S is equal to n minus 2 times 180, right? This is the formula. So if we were to use the formula to do this, it's the same steps, but it just looks different because you're writing it out with like very specific math grammar. In that case, we're just writing it in a formula. So the S is the 540 is equal to n minus 2 times 180. To solve this, you would first divide both sides by 180. See, our first step is still dividing by 180. So what's 540 divided by 180?
3.
3, good, is equal to, those cancel out, you just get n minus 2 left over. And then remember we said our second step was adding 2. That's exactly what we need to do to get our n by itself. So when you add 2, what's 3 plus 2?
5.
5 is equal to n. So you can still get the same answer. N is the number of sides. You can still get 5 as the number of sides with the formula or with just reversing the steps. Either way, it's the same thing. Because if you look at the steps we did, we first divided by 180, right? And then we added 2. It's literally the same thing. Let's do one more with the formula and then skip 5 and 6. So S is equal to n minus 2 times 180. Okay, 1, 2, 6, 0 is equal to n minus 2 times 180. First step is divide by 180. What's 1260 divided by 180?
7.
7 is equal to n minus 2 because those cancel out. Then our next step is to add 2. What's 7 plus 2?
9.
9.
9 is equal to n. Good. Good job, guys. And as you might notice, the steps are the same. We first divide by 180, then we add 2. Same steps, just a different way of looking at it. So hopefully you choose the way that you like best, write it down in your notes, and you use it on your tests. Do you guys have any questions? Okay. So somebody just needs to copy it, or maybe they have a question. If you're copying it, just type done when you're done. If you have a question, then type your question. We're almost done with these notes. This is like the furthest we've gotten on the notes. I'm so proud of you guys.
Yay.
Yeah, seriously, so good. Okay, cool. So you guys are done copying it, it looks like. We're going to skip 5 and 6 because I think you guys got the hang of it. We're going to go on to the, what's it called? Exterior angles. I don't know why my mind blanked. I was just staring at the words. Okay, F says, extend each side of the polygon to create one exterior angle at each vertex. So you can choose to do it, like you can choose to extend, let's talk about this corner. You can choose to extend this one or this side. Either of these sides is okay, but I'm just gonna do it this way. Just because. You can do it the other way. So if I'm extending out that way, I'd like to keep it consistent and just go like that. Kind of make it like a windmill, okay? A windmill. And we're just gonna practice drawing this, okay? So I just like to make my windmill kind of like go clockwise. So I'm gonna extend for number 2, like that, and like that, and like that, like that, and like that. It's totally okay if you go the other way, but each corner should only have one extra line sticking out of it, okay? So let me show you something that's wrong. Do not have like this, where you have 2 lines coming out of the same corner. That is wrong. Do not have 2 lines coming out of the same corner like that. You only want one of your lines. So for me, I chose this one. Okay? Let's say you like to reverse it the other way. Let me show you what the other way would look like. Or extend it the other way, I mean. So you can make it come out the other way. That's totally fine. As long as you only have one line sticking out from each corner. Do not do 2, okay? So let me do another one. Okay. Any questions about 1, 2, 3, 4?
So we're only supposed to add one line.
Yeah, one line for each corner. Okay, let's do the 5 and 6. I'll just do this one this way. If you go the other way, it's okay too. That's not very straight, so I'm gonna fix that. Okay, that was my best attempt. It kind of looks like a messy Christmas wreath. And then I'll do this one the other way. Reverse. Not very straight. There we go. Okay, you know what? It's okay if it's not straight. Online teaching is hard. Drawing on an iPad is hard. Oh gosh, that's so ugly. It's okay. So extend one line out from each corner. Don't you dare put 2 lines on a single corner. It's got to have just one line on the corner, okay? Any questions? 1, 2, 3, 4, 5, 6. And you guys got 10 seconds to say wait or yes, so that I know. Okay, I will wait. Please type done when you are done for the person who said wait. That way I know that when you're done, then everyone's done. Okay. Oh, wait. Yes, okay. Cool. Then let's go to the next page, which is our last page over here. Calculate the sum of the measures of the exterior angles for each polygon. So for this one, we don't really get to do a little discovery like we did for the interior angles. However, let me refer back to our notes. For exterior angles, nope, not this one. Sum of the exterior angles of a polygon is always 360 degrees. It doesn't matter how many sides it has. It literally says that it does not matter how many sides it has. Okay, so 360 degrees for the exterior angles. So then back to our skills practice. A pentagon. What is the total measure, total sum for a pentagon?
Like, I don't even know.
Take a look at the notes. What is the answer?
360.
360, good. For the exterior angles, it's always 360. Now what about for a hexagon? Take a look at the notes. What is it?
360.
360, great. What about a triangle?
180.
80.
Okay, so it's 360. When you said 180, you're thinking the interior. So we're talking about exterior, okay? Easy mistake to make, don't worry. What about a nonagon? That's just 9-sided.
360.
360. What about a 20gon? They were too lazy to come up with a name.
360.
What about a 150gon?
360.
Perfect.
360.
Congratulations, guys. We finished our guided practice. Do you guys have any questions on the last section? Alrighty, I'm gonna stop recording.